design a digital filter using finite impulse response system. Finite impulse response system. Finite impulse response system क्या होगा? जिसके impulse response की number of terms finite होंगी. ठीक है? Number of terms finite होंगी. Okay. So let us suppose there is an ideal filter. An ideal filter is given whose response is given as 1 and 0 in between minus pi by 2 to omega 2 pi by 2. Okay, 1, and it is pi by 2 when mod of omega is greater than pi by 2 and pi. Okay, this is ideal low pass filter. Ideal low pass filter because omega, when omega is in between some pass frequency, omega p is pi by 2, then it is passing the frequency, and it is, if it is greater than that, then it is suppressing that, 0. Okay, so it is an ideal low pass filter, and we have to design this filter by using FIR method. FIR implementation. FIR implementation means we have to determine HN. We have to determine HN, and since it is finite length, so we need to know how many terms we need to determine. So here it is telling us that the number of terms is 11. Number of terms is 11. Okay, number of terms is 11. So our aim is to design a finite impulse response digital filter which will be having ideal response as this, and number of terms here will be 11. Okay, so we know that what will be HDN, क्योंकि n डोमेन से जब हम ओमेगा डोमेन से जब हम n डोमेन में जाते हैं, then we have to perform this transformation, 1/2 pi minus pi to pi HD e raised to power j omega, e raised to power j omega, e raised to power j omega n d omega. Okay, this will we have to, this transformation will transform omega domain to n domain. Okay, and when we do this, since we have been given this value, when we substitute it here, we will get it, since it is non-zero between minus pi by 2 to plus pi by 2 and e raised to power j omega n d omega. When we do it, we will get it to be sine pi by 2 n, sine pi by 2n divided by n pi. Okay, where of course n is not equal to 0, when n is not equal to 0. Okay, so this is the HDN. This is how, if HD j omega is given, we can find out HDN by using this transformation. This is rectangular window approximation, and since the number of terms are given m to be 11, so we know that what will be the n. So n will be 5. It will be 5 plus 5 plus 1 will be 11. So it will be sine pi by 2 n divided by n pi divided by n pi and 0. So we defined it to be mod of n less than 5. If it is less than 5, then it will be like this, and 0 when n mod of n is greater than 5. Okay, when n mod of n is greater than 5. So this is hn. This is hn we have determined. Since filter coefficients are symmetrical, this function is that such that h of n is same as h of minus n. So it is symmetrical about 0 because of this function. Hence, we need to find out only 5 different values. Of course, we have to find out the for n tending to be 0 also. So what will be h0? H0 will be within the limits n tending to 0 and this function. So it will be equal to, इसकी लिमिट निकाल लेंगे 1/2, since pi भी है यहाँ पर सब कुछ है, so its value will be 1/2. यहाँ पे 1/2 से multiply कर देंगे, this thing will be 1. Okay, so h0 will be 1, will be half. h0 will be half. Now what will be n equal to 1? n equal to 1 और -1 के लिए दोनों के लिए सेम होगा, ठीक है. So h1 और h-1 will be equal to sine pi by 2 divided by pi. It means 1/pi equal to 0.3183. ठीक है. Similarly, n equal to 2 and -2. n equal to 2 and -2. So h2 and h of -2 both will be the same. And what will be their value? Their value will be sine pi upon 2pi. Sine pi upon 2pi, and sine pi is 0, so its value will be 0. Similarly, n equal to 3 and -3, दोनों इक्वल होंगे h3 and h of -3. So it will be sine pi by 2 divided by 3pi by 2, 3pi by 2 divided by 3pi, and its value will be -1.06. Okay. Similarly, n equal to 4 के लिए और -4 के लिए दोनों के लिए सेम होगी, यानी कि h4 and h of -4, and its value will be sine 2pi divided by 4pi. Sine 2pi is 0, so this will be 0. Similarly, last one will be 5 -5 hn and h5 and h of -5 both will be equal. And what will be its value? Its value will be sine 5pi by 2, sine 5pi by 2 divided by 5pi, and its value will be coming out to be 0.0063, sorry, its value is 0.06.06366. This will be the value. So total number of terms are 11. Total number of terms we have determined to be 11. So this will be how, and what will be the transfer function? For transfer function will be, since ये 11 terms होगी, and what will be the transfer function? Transfer function will be hz, क्योंकि ultimately we have to determine, किसी भी filter design में we have to determine hz so that this filter can be realized. So what will be hz? hz हमने डिस्कस किया था, इधर यहाँ पे डिस्कस किया था ना hz. This will be hz. Okay, and since hn is given, when hn is given, you can determine hz. Hn is given. What is hn? Hn is this. So hz will be minus 5 to 5 minus 5 to 5 hn z raised to power minus n, just like this. And we have all the values. So what will be hz? Hz will be 0.6, sorry, 0.6366 z raised to power 5 minus 0.106 z raised to power 3 plus 0.5 0.5 से पहले एक z raised to power ये भी आएगा 0.3185 z raised to power 1 plus 0.5 like this, and then it will be here like this, z raised to power minus 1, and it will be here minus, या minus आ जाएगा, and this plus this, okay, plus this. So this will be the hz. So you can see here that hz has, since hn has finite number of terms, so hz will be implemented like this. Okay, this will be the hz. Okay, third year designing is done. Okay, and this can be realizable by using the, here you can see that, because what will be the output? Output will be yz equal to this whole thing, and this whole thing multiplied by xz, this whole thing multiplied by xz. So here you can see that the output yz is not depending upon the past values of output. There is no feedback, hence therefore this design is basically a finite impulse response design, where the output is not depending upon present or the past values of the output. In fact, it is depending upon the future values of the input and the past values of the input. Okay, and the past values of the input. Okay, so signals flow in the only in the forward